Down question number 21. I've already filled in the parts that we know. We know it's a parallelogram, so opposite sides need to be congruent. So I'll take 2x plus y is equal to y plus 4. And then the other equation is going to be 3x plus 6 equal to x plus y. You start to see you got two variables in both equations, so you want to start setting this up so you got a system of equations. But once I start subtracting y from both sides, I get 2x is equal to 4, so now x instantly ends up being 2. Okay, so it solves this equation here solves for one of the variables without us having to use another equation, which is nice. It now eliminates A and C as answers. If I know what x is, now I can come over here and say, well, 3 times x, which is going to end up being 6 now, plus 6 is equal to 2 plus y, so I get 12 is equal to 2 plus y. Subtract 2 from both sides, get y to be 10. So that tells me that option B has to be my answer. It says with your x and y from question 19, I guess it shouldn't say from question 19, it should say from question 21. Find AB and BC. Well, AB is going to be x plus y, so x plus y is 12, and BC is going to be y plus 4, and y was 10, so 10 plus 4, so 12 and 14. So AB is 12, BC is 14, so that's got to be option D. Question 23 says, identify whether we know these figures to be parallelograms or not. We have a property or a theorem that says if one pair of opposite sides are both parallel and congruent, then it is a parallelogram. So yes. That theorem says if one pair is both parallel and congruent. Okay. Here we're showing one pair being parallel and a different pair being congruent. So that's no. I had a theorem that said if all four sides are congruent, or sorry, if I guess all four sides are congruent, or if both pairs of opposite sides are congruent, that would work. So yes, that is a parallelogram. And looking at this, we know that this diagonal here gets bisected, but we don't know anything about this diagonal. Okay, so the reason would be no, or the answer would be no there. Okay. At number 27. Again, we want to find x and y, given that this is a parallelogram, so I'm going to take 2x plus 5y is equal to 30, because I know opposite sides are congruent. And now I'm going to take 2x and 2y, or 2x plus 2y is equal to 18, because I know that the diagonals bisect each other. So I'll say 2x plus 2y is equal to 18. Now I recognize that the x's are the same coefficient. I just need to change one so that it's negative. So I'll make this negative, make that negative, make that negative. Add down, that'll go away. This will give me 3y. This will give me 12. So y ends up being 4. Okay, now this is a test-taking strategy. If I know y is 4, come over here. You've got options. It can't be that one, can't be that one, can't be that one. It's got to be that one. Don't even need to solve for x. Okay. Moving down to question number 28. We know that these are midpoints, that there's a midpoint and that there's a midpoint. So this mid-segment is half the length of this side over here, and it'd be parallel as well. So I want to say that 7, it's half of 5x minus 3y, or we could say 2 of these 7s will make up one 5x minus 3y. And for this question, it's probably best to say 2 of those 7s make up 5x minus 3y. So 2 times 7 is 14. I know because this is congruent to that. I can say 3x minus 2y is equal to 8. I don't recognize um, coefficients to be the same. So I need to just choose a variable that I want to cancel out. I'll cancel my y's, so I need to make them both become 6. So I'll multiply this top equation by a 2. I'll multiply this bottom one by a 3. Now that'll make them both be negative 6. I want one of them to be positive 6 and one of them to be negative 6, so I'll change that one to a negative 3. I could have made this one negative 2 if I wanted to, and kept that one to be positive 3. When I multiply this all out, I get 10x minus 6y is equal to 28. I'll get negative 9x plus 6y is equal to negative 24. When I add straight down, I'm going to get x here, my y's go away, and I'm left with 4. Okay. Another test taking strategy, come over here. Are there, x can't be that one, can't be that one, can't be that one. It's got to be that one. I don't even need to deal with y. Okay. Sometimes on an OGT, you could be able to eliminate 2 of the questions, and then the y's would be the same, and you got to determine what the y is. But once I know what x is, I can take it back up into any one of the equations that I've made throughout the test or throughout the question, and plug it back in and solve for y. 29, find TD. Okay, TD is this segment here, and I'm going to find that segment by looking at this triangle right here. Okay, TD is a mid-segment of that triangle, so I'm going to say the mid-segment, which is 2x plus 6, should equal half the base that's parallel to, or the side that's parallel to, so 2x plus 2y. Start multiplying. I get 2x plus 6 is equal to, multiply that 1/2 through, I get x plus y. So now I have 2, I'll move the x and the y over, so I'll get, subtract x here. I'll get x plus 6 is equal to y. Moving my y over, I'll get x minus y plus 6 is equal to 0. So I'll be left with x minus y is equal to negative 6. Okay. So looking at that triangle really didn't help me find what TD was. It didn't help me solve for x, or it didn't help me solve for y. So what I want to do then is look at another relationship that I see in this figure, and now it's looking at that trapezoid, with this segment here being the mid-segment of that trapezoid. So I can take So now I want to look at this trapezoid with the purple segment being a mid-segment. I know that the purple segment, the mid-segment, is going to be half the sum of the 2 bases of the trapezoid. So say 2x plus 2y is going to be half of 2x. Now if I add these two things together, I'm going to get 2x plus 78. Okay. Because these two things are even numbers, I'll just go ahead and distribute my 1/2 through. I'll get 2x plus 2y is equal to x, and then half of 78 is going to be 39. I'll subtract x from both sides, so we get x plus 2y is equal to 39. So now I'm going to take this equation here and this equation here and solve for my variables x and y. So in order to do that, I need to set up a system equation, so I'll take x plus 2y is equal to 39, and I'll take x minus y is equal to negative 6. I'll just multiply this bottom one by a negative to get my x's to cancel out. So it gives me 3y is equal to 45. So y is going to be 15. And if y is 15, x has to be 9 if I plug it into this to solve for x. So x is 9. Okay. Now that's not what the question asked. The question was find TD. So TD was 2 times x plus 6. Well, 2 times 9 is 18, plus 6 is 24. So C is your option there. 30 says find ZR. Well, ZR is 2x plus 2y. Well, 2 times x, 2 times 9 is 18, plus 2 times y. Y was 15, so 2 times that is 30. So I get 48. So C is my answer for ZR. Okay. Okay, this question, this figure is a rectangle. If A to C is x squared, the diagonal is x squared, and d to b is 6x minus 8. That's another diagonal. We want to set those two things equal to each other because diagonals of a rectangle are congruent. So I get this. I want to solve for x, so I need to set everything equal to 0. So I get that. And I'm looking for two things that multiply together to give me 8 and add up to give me negative 6. So it's x minus 2 and x minus 4. So x will be positive 2 and x will be positive 4. If I try either of these values, 2 squared will give me positive 4, 4 squared will give me positive 16. So both values work for that segment. 2 times 6 is 12 minus 8 is 4, so 2 works for this one. And then 4 times 6 is 24 minus 8 is 16, so both those are positive values for that one. So D works. Okay, both answers are solutions. Here we have a trapezoid, so I know that the mid-segment 8 is equal to half the sum of the two bases, so I get x squared plus 3x minus 12 plus x squared plus x minus 2. I got 8 is equal to half of, it's going to be 2x squared. I'm going to have 3x plus x is 4x, and then negative 12 minus 2 is negative 14. So that's nice because now I'm going to distribute my 1/2 through. I get 8 is equal to x squared plus 2x minus 7. I'll subtract 8 from both sides. I get 0 is equal to x squared plus 2x minus 15. Now I can factor that, and I want to find two numbers that multiply together to give me negative 15 and add to give me positive 2. So that's negative 3, positive 5. So x is going to equal 3. X is going to equal negative 5. Well, that's when this is equal to 0 again. Checking my answers. If I try 3, I'll get 9 plus 9 minus 12. I'll get 9 plus 3 minus 2. Both those give me legal values, so I know 3 for sure works. If I try negative 5, I'll have 25 here, minus 15 minus 12. Well, that's a total of 25 minus 27, which gives me negative 2 for a distance. I can't have negative 2 for distance, so that answer does not work. My only option would be C. We've seen these properties so many times. I'm going to go through these pretty quickly on just the answers. Obviously, these are all in your textbook for theorems, definitions, all that kind of stuff. You should be able to find those and verify to yourself the reason why these are true. Opposite sides are parallel. It's true for all of them. Opposite sides are congruent. It's true for all of them. Opposite angles are congruent. It's true for all of them. If it's true for a parallelogram, it's true for all of these because all of these are parallelograms. A diagonal forms two congruent triangles. That's true for all of them. Diagonals bisect each other. That's true for all of them. Diagonals are congruent. That's only true for a rectangle and a square. Diagonals are perpendicular. That's only true for a rhombus and a square. A diagonal bisects two angles, rhombus and square. All angles are right angles, rectangle, square. All sides are congruent, rhombus, square. Has a sum of interior angles to be 360, all of them. Working on this proof, parallelogram EFGH is given. Okay, so that's going to be what? E. EF is parallel to HG, and EH is parallel to, EF is parallel to HG, and EH is parallel to FG. Okay, the reason we know those to be parallel is because we know this thing's a parallelogram. That's the definition of a parallelogram. So this should be option B. If these are parallel lines, if that's a parallel line, that's a parallel line, This here's a transversal, so I know angle 1 is congruent to angle 2. So that part right there. And also if I looked at that, oh, that's terrible. Look at that parallel line right there, that parallel line there, cut by that transversal, you can see that angle 3 is congruent to angle 4. Apologize for that being sloppy. But, 3 and 4 is right there. So we know that we want angle 1 congruent to angle 2, angle 3 congruent to angle 4. Again, if two parallel lines are cut by transversal and alternate interior angles are congruent, that's my reason. My statement should be AD over here. The reflexive property, the only thing on here that's reflexive is showing AB, which hopefully that makes sense because that's the segment we need to show this triangle up top congruent to triangle on the bottom. And they're congruent by angle, side, angle. So triangle EHF is congruent to triangle GFH by angle, side, angle, which is A. And now if that's true, I know that this stuff, BC, the things I want to prove, are congruent. This side here, E to H is congruent to F to G, and I know that E to F is congruent to H to G because they're corresponding parts of congruent triangles. So 49 is BC. If you have any questions about any of these, make sure you come see me. Remember, the retake is 7:30 in the morning.